Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from power system stability, and the topic is equal area criteria. Basically, this equal area criteria is used for the quick prediction of a stability. Now, which stability can be analyzed by equal area criteria? The answer is a transient stability analysis. This is very simplest method which can be used, and here we are not going to solve any swing equation. So the transient stability analysis of the simple system that can be performed without solving any swing equation is called as the equal area criteria. Now during this state, two situations may occur for changes in the load angle delta with respect to time. If the load angle delta between two machines is increased to a maximum value and then it is going to decrease, or in other words we can say if it oscillates with a constant amplitude, then it is considered as a stable. Let's say I'll draw this diagram here. This is your time t. This will be load angle delta. So let's say if your load angle delta, it will increasing then decreasing, and if it will oscillates and then it will become at steady state, then the system is called as a stable. On the other hand, if the load angle delta is go on increasing continuously of a two machine without having any limit, then the system is considered to be unstable. So this is the region which shows that the system is unstable, and this is the region which shows that system will be stable. For a one machine system, swinging with respect to an infinite bus can be analyzed with the help of simple equal area criteria without solving a numerical method. So this is what is, we can say, the most important advantage of transient stability analysis method, that is equal area criteria. Because if we want to use a swing equation, then it involves a large number of calculations and it is a time consuming. So the use of this method eliminates partially, or we can say totally, the calculation of swing curves or the swing equation, and therefore it saves the considerable amount of the work. This method is applicable to any two machine system. Please remember, this is very important point, but it is not applicable to a multi-machine system directly. Now already we have studied a swing equation. We have gone through a swing equation in a previous videos. So for that case, now I will draw a diagram here. Let us consider there is a one generator having some reactance xd dash, reactance of the generator. Then this is your reactance of the line x1 simply, which is connected to infinite bus bar whose voltage is V equal to 1 per unit or 1 at an angle 0. This will be E dash at an angle delta, let's say. Now what is the swing equation? Md square delta upon dt square equal to Pm minus Pe. We can write it as equal to Pa. Now what we have to do is multiplied here both side by the term 2d delta by dt. So what you will get? 2 this md square delta upon dt square as it is. Here we have multiplied by d delta by dt on left hand side. On right hand side, this is Pm minus P, or simply you can write Pa also, 2d delta by dt. So I will take this, let's say this is as equation number A suppose, and I will take this as a equation number B. Now what we have to do, integrate above equation number B with respect to t with the limits of delta 0 to delta. Now the question is why we have multiplied it with 2d delta by dt. So there is a rule of integration f of x into f dash of x dx will be equal to f of x bracket square divided by 2. So if you observe these two equations here, this is nothing but your f of x and this is nothing but your f dash of x. So once we take an integration, then what we will get? In place of f of x you put d delta by dt. In place of f dash of x you put d square delta upon dt square. So if you integrate it, we will get what? F of x square divided by 2. So I will write it here, d delta square d delta upon dt whole bracket square, which will be equal to what? Now here if you see here, what we have to do here, it will be divided by 2 term will be there, because f of x square upon 2, this 2 will be here as it is. So 2 into d delta by dt bracket square upon 2 will be equal to integration with the limits from delta 0 to delta 2 by m pa d delta. So how I can write this expression? Can I write like this? I will write it like this. D delta by dt will be equal to what? This 2 will get cancelled. This 2 will get cancelled. D delta by dt equal to square root of integration delta 0 to delta 2 by m pa into d delta. Now we know that for a system to be stable, what should be there? D delta upon dt should be equal to 0. So if I put it here, d delta by dt will be equal to 0. So I can write it like this. If I take squaring on both sides, this will be 0. This will become what? Integration delta 0 to delta 2 by m into pa into d delta will be equal to 0. Can I shift this 2 by m right hand side? Yes, I can shift. So what I will get? I will get equation as delta 0 to delta pa into d delta equal to 0. Now what this delta 0 indicates? This delta 0 is the torque or the load angle at which the machine is operating while running at a synchronous speed under normal condition. Please remember, 0 is nothing but initial condition or normal condition. Under normal operating condition, torque angle was not changing. That is, before the disturbance, d delta by dt equal to 0. That's why here I have written d delta by dt equal to 0 means what? For a system to be stable. Now whenever there is a sudden disturbance is applied to the torque angle delta, it will start increasing with respect to time. Already we have seen this. Here, if this increment in the delta continues in the given period of a time, that is, if d delta by dt is greater than 0, then system will be in unstable state. So which is shown here in this diagram. This diagram is called as a swing curve. This is the curve or plot which is drawn in between time t on x-axis, delta on y-axis. So if rate of change of load angle delta with respect to time is greater than 0, which is shown by this curve, then that will be unstable. But on the other hand, if this d delta by dt equal to 0, that is the rate of change of load angle delta with respect to time is 0 for a given period of the time, then what we can say? We can say that this system is a stable. So this is what is the plot of delta versus time, which is also called as a swing curve, which shows a stable and unstable system. Now already we have discussed this point here about, we got this expression integration pa d delta equal to 0 with the limits delta 0 to delta. Now how we can represent this in a graphical form? So if you see, this is your delta 0 which is shown here. This will be a delta. Then pa d delta. Pa means what? You know, pa will be equal to pm minus pe. Pa will be equal to what? pm minus pe. So what this equation indicates? It indicates area under accelerating power curve from limit delta 0 to delta must be equal to 0. This is the mathematical expression of equal area criteria. Again I will repeat. Area under accelerating power curve from the limit delta 0 to delta must be equal to 0. Now what you observe here, this means that from this area under PA should be 0. Now when it will be possible? When your PA will be equal to 0, you know that PA will be equal to PM minus P. So it is possible only when mechanical input power and electrical power will be same. Or on the other hand, we can say that both accelerating and deaccelerating power, that is for a part of the curve, if PM is greater than PE and for other part PM is less than PE. So if you see here, this is the area A1 which is accelerating, this will be area A2, this is your deaccelerating area. Why this is called as accelerating area? Because if you observe, the diagram is like this. This is your upper limit and this will be your lower limit. Upper limit is PM, lower limit is represented by this curve PE. So PA will be equal to what? PM minus PE. If PM is more than PE, then PA will be positive. So that's why this is accelerating area. And if you see for area A2, it is represented like this. So this will be your PE, this will be your PM. So but obvious what you will get? PM will be equal to, PA will be equal to PM minus PE. More PE than PM, then you will get negative answer, which is called as deaccelerating area. So for the generator action, PM is greater than PE for the positive area A1 and PM is less than PE for negative area, that is A2. Now whenever these two areas, that is area under the curve, will be exactly equal, what you will observe? What you will observe here, you will get accelerating power will be equal to 0 and the system will be stable. So what we can say from this diagram? The system is stable if the area under P delta curve reduces to 0 at some value of the delta. Or in other words, we can say the positive, that is accelerating area under P delta curve, must be equal to negative, that is deaccelerating area of a P delta curve. This is called as equal area criteria. What this area A1 represents? It represents the kinetic energy stored by the rotor during acceleration, whereas this area A2 represents the kinetic energy which is given up by the rotor to the system. So this is what is equal area criteria. If you have any doubt, you can ask the questions through a comments. Thank you. Subscribe my channel.